Today's lesson is on section 3.7, day 2, implicit differentiation, and these are more examples of scenarios you might come across in implicit differentiation. The first one is where we have sine of x times y. That's kind of the new part in this example, a fun example, and you need to know it. All right, so we're going to take the derivative of sine using the chain rule. So derivative of sine, which is the outside function, derivative of sine is cosine, and keep that angle the same, xy. Then we have to take the derivative of xy. Sometimes we write that like this. The derivative of xy. All right, and then we're going to take the derivative of the rest of this equation. 6y squared dy dx. Now remember, the derivative of 4 is 0 equals 9x squared. Whoops, we only need a 6y here, don't we? All right. Okay, so that looks good so far. Let's look at the derivative of x times y. This is product rule. So u is x, v is y. U prime equals 1. V prime equals 1 times dy dx. All right, so when you write this out, and keep it in a bracket because the cosine has to be distributed to both of these terms. So cosine xy, and that's going to be multiplied by x times dy dx plus 1 times y. Okay. Let's distribute our cosine of xy to both terms inside the bracket. Please be very careful doing this. Don't forget your algebra skills. We multiply cosine times x dy dx. I rewrote it a little bit. I'm going to put the y in front on this term, cosine xy, and then we're going to write the rest of our implicit differentiation. We also then want to collect the dy dx's on one side of the equation, which means I'm going to move this term to the other side. That will go away. Let's group these two terms that have the dy dx's. So dy dx. And the two things that are multiplied by dy dx are x cosine of xy and plus 6y. All right, and that equals 9x squared minus y. See there? Y times cosine of xy. Now we're going to divide both sides by what's on the left next to the dy dx. And that is our derivative function right there. All right, so same thing we've done before. Just notice when you have an xy angle, you have to multiply times the derivative of xy, which is x dy dx plus y. That's the derivative of the xy. Okay, next example. Find the second derivative. Okay, some of these problems can get a little messy, so we're going to work on this one. We'll find the first derivative, then the second derivative. The big difference here is that when you get your first dy dx and you take your second derivative, you are going to do a little substitution trick. So Now, after a while, you can start doing these derivatives like I am. The derivative of y squared is 2y dy dx. Hopefully you're already doing them like this. The derivative of 2y is 2 times dy dx. And the derivative of 2x is 2. The derivative of 1 is 0. Big mistake is always made. If you want to, right at this point, you could get rid of all those 2's. Divide everything by 2. And that just makes your equation just a little bit simpler. These cancel out. So you end up with y plus 1 dy dx equals 1. All right, so you divide both sides by y plus 1, and that's going to be your derivative, first derivative. Okay, so we have 1 over y plus 1. Okay, second derivative. I'm actually going to rewrite this to be y plus 1 to the negative 1, so it's easier for me to take the derivative, the second derivative. All right, so remember we use notation for the second derivative, d squared y over dx. It's not really squared, it's the second derivative notation. All right, so to take the second derivative, I'm going to take negative 1. Oh, this is an outside-inside, by the way. Subtract 1 from negative 1, you get negative 2. So multiply by the exponent and then subtract 1. Leave this y plus 1 in there, but don't forget to multiply by the derivative of the inside. The derivative of the inside is just dy dx, or 1 times dy dx. Okay, so that is the derivative, the second derivative. Now, the one thing that I said you're going to do that's different, you're going to take dy dx equals this. You're going to plug that into this equation. So, d squared y is, this is like negative 1 over y plus 1 squared, correct? And then, actually, let's plug in this version of the derivative, 1 over y plus 1. So multiply times 1 over y plus 1. And our derivative of the second order becomes negative 1 over y plus 1 to the third power. And that is how we find a second derivative. We're always plugging in the first derivative, dy dx. We're plugging in whatever that value was into this second derivative equation. And that's really the only difference between finding the first and the second derivative. Your next examples are all about the rational power rule. So whenever you have square roots, cubed roots, fourth roots, rewrite them. Rewrite them to use rational or fraction exponents. Okay, so you change the roots, and then taking your derivative is fairly simple, right? You do y prime equals x minus 3. We're also going to have to use the chain rule here. 1/2 minus 1 is negative 1/2, and we multiply in the front by positive 1/2. Now, the derivative of the inside is the derivative of x, which is just 1. In this case, it doesn't really make a difference. It's just times 1. But in other cases, you may have a derivative on the inside, so just be careful not to forget about that. So this problem you could see written like on a multiple choice test, like this. 1/2 x minus 3 to the negative 1/2. That is also a possible solution. So be careful that you know all the ways that your derivative can be written for those multiple choice options. All right, x to the 3/5. We did a lot of work on those first problems, so these are a little bit simpler, less messy. Okay, 3/5 minus 1 is negative 2/3. All right, and that is that derivative. If you had to rewrite this, remember negative means the x is in the denominator. 2 means it's squared, power over root. Always remember you're exponents are power over root, and the negative exponent sends it across the line and changes the sign. Sine of x to the negative 2/3. Okay, this one we're going to need to use the chain rule and the power rule. So let's multiply by negative 2/3 times our parenthesis. We're going to subtract one. I believe that's negative 5/3 times sine. And sine of x is our inside part. So the derivative of the inside is going to be cosine. All right, so you might write this negative 2 cosine of x over 3 sine of x to the negative 5/3. Again, make sure you know what 5 over 3 means. Sine of x to the 5th and the cube root of that, or vice versa, and then it's set down below the fraction bar. All right, dy dx for this. And I could be writing these dy dx. Remember, it means the same as y prime, means the same as f of x prime. Those are all different ways to write the derivative notation. All right, power rule on the outside. 3/5 minus 1 is a negative 2/5. And we're going to multiply the front of this by the 3/5. Now inside, we have 6 minus x cubed. So we need to take the derivative of that and write it on the outside. The derivative is negative 3x squared. Negative 3x squared. And that's our answer. Let's rewrite it. Negative 9 over 5. And we could write this to be a little fancier if we wanted. This could be written 5th root 6 minus x cubed to the 2nd power. That's another way that this could be written. So just so you know that. Just negative 9 be in the middle here a little bit more. Negative 9 over 5. And I need to bring down my x squared here, so make sure you don't lose part of the answer. All right, last example is a 3-chain link, and it's a cosine function. So we have a couple of things in here. Okay, this is our outside function is something to the 4/5. So let's take the derivative of that first. We multiply 4/5 in front of our parentheses. And what's inside the parentheses doesn't change for this first part. We subtract 1, we get negative 1/5. All right, so let's copy down what we have. X squared plus pi. Remember, pi is just a number. And we're going to take the derivative of the inside and multiply it. The derivative of cosine is negative sine. And we have an inside function here as well. That inside function is x squared plus pi. Don't change it. Leave it the same. But now we're going to take the derivative of it. The derivative of x squared plus pi is just 2x. The derivative of pi is 0 because pi is just a number. This is your answer. Let's rewrite this just to make it look more presentable. We have a negative, a 2, and a 4. So that's negative 8. We have an x that goes on the top, and we have a 5 down here in the denominator. All right, then we have a sine. I already accounted for my negative on the sine. X squared plus pi, and we have a cosine of x squared plus pi. And that is the end of our lesson. 3.7, day 2.